All right, guys, let's continue on with section 15.8. 3. Triple integral in spherical coordinate. Well, in order to figure out the triple integral, the setup, we're just gonna take a look at one block. Well, there is one block. If you look at the left side, small, but when you blow it up, it looks better. So look at this block right here. We just want to figure out the volume of this block. I hope that everybody see what is going on in here. The easiest one is the change in the radius of the sphere. So that's the dp right here. Change in radius, everybody see. D rho okay, this change in the arc length here, rho d phi okay. One more, because we have the height, we have the width, and we just got to figure out the length of the width. So one more is going to be this one right here. Okay, so what is that? That is this arc length right here. Remember, this arc length is on the xy plane, so it's all d theta. So we have another one. This all d theta, but then all d theta is, well, all is rho psi phi d theta. And then from there, you have the base area times the height, and you get the volume of one block. dV. Well, of a sample block is going to be a base area times height. Base area is the rho d phi multiplied to rho psi phi d theta, and then the height here is d rho. Put them all out, you get the rho square psi phi d rho d theta d phi, or can be d phi d theta. Integral from negative 2 to 2. Integral negative root of 4 minus x squared, root of 4 minus x squared, integral 2 minus root of 4 minus x squared minus y squared, 2 plus root of 4 minus x squared minus y squared. x squared plus y squared plus z squared to the power 3 over 2 dz dy dx. This thing is density. And then the other one is volume. So we are computing the mass. So this is the mass of an object having that density. And what is the object here? Let's take a look to see exactly what is the object. Is we know z go between 2 minus 4 minus x squared minus y squared. 2 plus 4 minus x squared minus y squared. Okay. Yeah. This one. You will see that, well, z is equal to plus or minus, right? Root of 4 minus x squared minus y squared. And we say that z minus 2 is equal to plus or minus root of 4 minus x squared minus y squared, and then z minus 2 squared 4 minus x squared minus y squared. So move everything to one side. X squared plus y squared plus z minus 2 squared equal 4. There's a sphere operated to center at zero, 0, 2. Okay, so we know the exact object. Now we can sketch it out. Or the object. Actually, let me just write a solid here. Okay, so okay, x squared plus y squared plus z squared, that's rho squared, so that take care of the density. It's the volume that we need to take care of here. dv is the, well, we just did it here, rho square psi phi d rho d phi d theta. Where does rho go from? Where does the angle phi go from? Where does the angle theta go from? Once we have everything, we can do the setup and get through this problem. Phi is the angle that go from the z-axis. So if you look up here, this phi here, it go from here all the way down here. So this your phi, right? So phi go from, according to the solid here, it go from 0 to, well, to the xy plane. So how to? The angle theta is the angle theta that is on the region D. Region D is this, the entire disk. Yeah. So the angle theta is, this is the angle theta here. Right. So let me, phi, yeah, is the angle theta. So it's going to be 0 to 2 pi. Okay. Next one is the radius. So rho go from the origin up to the sphere. You see, rho here is different for every time I sketch the arrow. Right? So we got to figure out how to describe the sphere in term of rho. Yeah. It go from 0 to whatever that is. We can work out the sphere formula right here, and then work it out, and then do some. I'm gonna put this thing here, right? I'm gonna go down here, and then we're gonna work it out. Right? So for cosine phi, it's equal to the angle theta 0 to 2 pi, the angle phi 0, pi over 2, rho 0 for cosine phi. And then we know x squared plus y squared plus z squared. That is just rho square. 3 over 2. Multiply to dv is the rho square psi phi d rho d phi d theta. And then from here you see that you can definitely work out this integral. It's not that bad. I'm gonna focus the time on helping you guys to set up a few more problems. Work it out. You can do it. Make sure that you get the answer to be 4096 pi over 21. Find the mass of the solid. Having density. Well, because rho is, I cannot use rho for density, and just use f x, y, z here. Root x squared plus y squared plus z squared. And lies between the two spheres and inside the cone. Z equal root x squared plus y squared. Okay, so we have a cone right here, and then the two surfaces. Here come a cone. Okay, so one of the spheres is gonna be at the bottom, right? Of the cone. And then another sphere is going to be on the top. So this is the part of the cone right here. And then another one is going to be on the top. I'm just going to have to redraw this thing here. Yeah. This is what the solid look like. Need to triple integral. If set up in rectangular coordinate. One for the height 1 and the other one's for height 2. So height 1, everybody can see, right? From one sphere to another sphere. Root of 1 minus x squared minus y squared. Root of 4 minus x squared minus y squared. That is the first one. And then the second height is from the cone to the sphere. From the cone is the root of x squared plus y squared to the sphere 4 minus x squared minus y squared. So as you can see, much better if we set this thing up in spherical coordinate. So dv is rho square psi phi d rho d phi d theta. Where does the radius go from? Where does the angle phi go from? And where does the angle theta go from? Projection here first, so that you can see it. Project E onto a XY plane. So take care of that theta. Region D 0, 2 pi. This is the angle phi right here. Phi is from 0 to, well, that is pi over 4. You can actually work it out. So we just z equal to root of x squared plus y squared. So what is z here? Z is the, no, actually I'm gonna this z equal all, because the x squared plus y squared is all square. So z is rho cosine phi, radius is rho sine phi. So you can either do tangent or cotangent, up to you, right? It doesn't matter. So do cotangent phi equal 1. So I mean phi is the pi 4. That's where you get the phi from. And then the radius here, anybody? Yeah, 1 to 2. Very good. Yeah, 1 to 2. Yeah. Mass is 0 to 2 pi, 0 pi over 4, 1 to 2. And then the density is the root of x squared plus y squared plus z squared. So that's going to be a root of rho square psi phi d rho d phi d theta. You guys can work it out. It's not that bad. But if you work it out, then it would be number. Look later, later. 15 pi over 2, 1 minus root 2 over 2. Is shape and is density. So here come 1 pi over 2 to pi 0 pi over 2 1 to 2 rho to the power 3 sine square phi d rho d phi d theta. Okay, so we have a rho to be from 1 to 2, right? So this tells us that it is between two spheres here. Huh? Two spheres. Yeah. We have a phi to be from 0 to pi over 2, meaning that the solid is going to be above the xy plane, completely above. And it's gonna go between the two spheres above the xy plane. And the last information here is going to be like you say, is in the second quadrant. Pi 2 to pi Q2 is when projected onto xy plane. Yeah, so exactly what the heck is the solid here? Solid S is a quarter of the region between the two hemispheres.